Sam, can you explain the significance of the Mobile MT survey conducted over the Rae Copper Project and how it enhances your understanding of the subsurface?
The survey is significant because really it marks the first project scale geophysical survey conducted at the Rae project. Even though it's been known for a while, the prospectivity of the region, before Whitecliffe have stepped in, there's been really no modern systematic exploration in the area. So you get two specific deliverables from the MobileMT survey. We've been given a magnetic dataset and an electromagnetic dataset. So the magnetics has aided us in defining both the structures, controlling structures for the mineralisation, as well as allowing us to really refine the geological mapping, which was done on a regional scale, especially the difference between the non-magnetic sediments to the north and the magnetic basalt. So that's a really key feature going forward into the targeting stage. The electromagnetic component has then allowed us to visualize areas of elevated conductivity, which may lead us towards the sulfide accumulations within the sediments.
And what are the unique advantages of using the MobileMT airborne electromagnetic technology for identifying conductive anomalies in this project?
So firstly, because of the scale of the Rae project, now sitting at over 1,100 kilometers squared, we needed an airborne solution. So MobileMT, we were able to cover the ground efficiently, and it's now given us a really powerful data set moving forward. The MobileMT technique does have certain benefits over other EM systems, such as time domain EM, whereby we have a better resolution in the resistive terrains, and also it offers a much greater depth of investigation. So it's been really key for us to define the large scale features within the project and the large scale mineral systems that we're targeting.
Could you detail the geological setting and structures of the Hulk District sub-basins and how these features contribute to copper mineralisation?
The Hulk district is targeting sediment-hosted copper deposits, specifically a reduced facies subtype of that deposit, similar to Kamoa and Kakula in the DRC. So the Rae project we've identified on a large scale to have all of the first order controls required to form such a deposit. We have both the basalt sequence and the Husky Creek red bed sandstone formation. In the upper part of the sedimentary sequence, we have evaporites, and that has the capacity to form metal transporting brines, essential for transporting the metal through the basin. We have a well-established fault network. So this has been proven to host copper mineralization during our sampling efforts this summer. And finally, we have the sink. So where the copper is going to end up, within the basal part of the Rae group sediments, we have some really reactive sedimentary rocks. Using the MobileMT data, we've been able to define new structures within the Hulk basin and separated it out into three separate fault-bounded sub-basins. And we can see from the MobileMT data that these structures within the sub-basins are creating differences in the architecture and the conductivity response. And this can be seen in figure 1 of the announcement.
And how does the orientation of conductive intervals in the Rae group sediments inform potential drilling locations and the exploration strategy moving forward?
Looking at figure 4 in the Hulk focused news release, you can see there's a gently north dipping zone of conductivity, which itself has hotspots of higher conductivity within. The fact this is north dipping is key because it matches the field observations from the Rae group sediments from this summer. We could see that they were dipping between 3 and 5 degrees to the north. So it's nice to see the field observations and the geophysical response marrying up, which gives us more confidence in the rest of the geophysical model. This will feed into the drill hole planning because it essentially means that in the south of the basin, we can target this shallow and progressively follow it to the north as it deepens.
Sam, what specific geochemical and geophysical indicators did the survey reveal about sediment-hosted copper deposits at the Hulk district? And what do these indicators suggest about the potential scale of the deposits?
So starting this summer with our boots on the ground work, we sampled up to 1.65% copper from quartz sandstones within the Rae group sediments. Now, this is located in the western part of the Hulk subbasins, and it's important proof of concept from a geochemical standpoint that the copper-bearing fluids have made it north into the basin. Geophysically, we can see that adjacent to these major structures, such as the Herb Dixon fault, that there is increased conductivity within the sediments. This is especially visible in figures 5 and 6 of the news release. This allows us to zone in on the most prospective parts of these sediments along the strike length of these regional structures. Now, in terms of scale and what this means, we now hold over 72 kilometer strike length of the Rae group sediments. So this really gives us the potential for multiple discoveries. And within the Hulk district itself, the conductivity anomalies we're seeing are kilometer scale. So that's really exciting for when we move into the drilling phase for upscaling the project.
And how does the Herb Dixon fault structure act as a fluid pathway? And why is it relevant for copper mineralisation in the Rae Copper Project?
The Herb Dixon fault is a major structure running north-south through the project for over 25 kilometers. It's clearly visible in both its topographic expression and a well-defined magnetic low. So such a structure offers a great zone of permeability for these copper-bearing fluids, and we know that the structure is associated with multiple historic copper occurrences along its strike length. Now, where this passes north into the Rae group sediments, that offers us the essential fluid pathway we need to get those fluids into contact with the reduced sedimentary rocks where you could form your reduced facies sediment-hosted copper deposits. The structure in its own right is prospective for mineralization as well. Lots of the high-grade mineralization we were sampling this summer is fault-hosted vein and breccia systems, so the Herb Dixon fault will feed into the project pipeline moving forward.
Sam, with the completion of the MobileMT survey, what are the next steps in Whitecliffe Minerals' exploration plan, particularly concerning drilling targets and future geophysical analysis?
It's a really exciting time to be part of Whitecliffe. We've had a great summer field program, the maiden field program for us on the Rae Copper Project, and now we're really focusing on the 2025 objectives. Drilling is the next step for Whitecliffe at the Rae project, and to define these initial drill targets, we're continuing to integrate all of our surface findings from this summer with our newly acquired geophysics and really comparing that to published ore deposit models to provide us with some robust targets to drill. Regarding geophysics moving forward, once we have drilled some holes, we can revisit the geophysical model and sort of calibrate that with our observations from the core, allowing us to search the wider area outside of the main Hulk district for further discoveries.